Thank you. Right, yeah, I'm Johan. Hi everyone, I'm really excited to be here. I'm a Swedish guy, I live in England. I work for a data collaboration startup called FOSDEM. I've been using Go for about 2 years, and I really like the language. In my spare time, I enjoy working on open source projects, and I've contributed to the Go programming language. I run my own blog, writing mostly about Go and gRPC. And today, I'm here to talk about my open source project and creating GopherJS apps with gRPC web. So let's take a quick overview first. Today, we're going to learn about protobuf, gRPC, gRPC web, and GopherJS. We're going to introduce gRPC web for Go. We're going to create a simple app with gRPC web for Go. So let's start with protobuf. Who's heard of protobuf before? Yeah, that's most of the room, as expected. And who's using it in production? This is about half the room. Okay, yeah, cool. So it's not going to be a lot of news for you. It's Google's interface description language, a binary serialization format built for backwards compatibility and leverages code generation. It is used for service-to-service communication as well as data storage. It's designed to be faster than XML, up to 100 times according to the Google documentation, however relevant that comparison is. It's faster than JSON as well, of course. It's got wide official language support, including Go, C++, Java, Python, other official implementations, as well as third-party libraries. And as far as I can tell, this is the highest resolution image that exists for the protobuf project. It's terrible. So what does the protobuf file look like? I've chosen a simple file here using Proto3 syntax, which is a modern way of creating proto files. I've also used the Go package option, which is specific to Go, but you should definitely be using if you're using protobuf with Go. It makes all your imports much easier to handle. We've got a package declaration here as well, which is used for namespacing packages, and we've got a really simple message declaration. And we've got a couple of different types here and some field numbers, which is used for marshalling and unmarshalling, and helps with the backwards compatibility guarantees that it gives you. Proto files also support more advanced features such as enumerations, arrays, maps, nested messages, and one-off types, and services, which we're going to come back to in a moment. So what does the generated code look like? So from that simple type description that we had in the proto file, we get a Go type. The types map very simply in the Go case. We get some struct tags for JSON and protobuf and marshalling, and we also get some getters. The default Go protobuf generator uses reflection for marshalling and unmarshalling, but there's a third-party implementation called GoGoProto, which uses type-specific marshalling. Thanks, Walter. Which you should use if you're using Go, because it's faster. So how do we use protobuf for service-to-service communications? gRPC. So obviously we've already been introduced to gRPC a little bit here today, but who's using gRPC at work? Well, that's quite a few actually, yeah. So it's a remote procedure call protocol developed by Google, built on HTTP2. It's donated to the Cloud Native Computing Foundation. It's serialization agnostic, but you normally use it with protobuf, although it does also have official support for flat buffers now. And like protobuf, you generate code from the protobuf definitions or the flat buffer definitions if you use flat buffers, of course. And it comes with powerful streaming capabilities, such as server-side streaming, client-side streaming, and bidirectional streaming, which is really useful for service-to-service communications, of course. And it's the backbone of Google's internal communications network. So what can we do with gRPC? So this is a page, an image from the official gRPC documentation, and essentially the idea is that it allows you to write polyglot microservice architectures, such as Google's, presumably. We've got a C++ server, Android client, and another Ruby client, and they just interact over the protobuf interface and the HTTP2 that gRPC provides. But you could easily replace the C++ service here with a Go service and this Ruby client with a Python client and so on. That's what it gives you. So what does it look like in the proto files? So we've taken the proto file that we had before, we've just added another type here, and we've added a service at the bottom with a method, a simple unary method that takes a cat toy request and returns a cat toy. And this then produces, this is a snippet of the generated code that it produces. You get for the client, you get a client-side interface that you can work with, and on the server side, you have to implement this interface in order to support the interface. So it's very simple. All of it, you just define it in the protofiles, and then you can, in the client side, just call the function essentially, and in the server side, you just implement the interface. Very nice. So, but can we use this in the browser? Yes, with gRPC Web. Who's heard of gRPC Web? That's actually more than I expected, I gotta say. It's a very new project. Well, it's been in development for about a year, as far as I know. But no, 2 years probably. It only has an official spec out yet. There's also an official client, but it's in alpha stage, and it's still being developed in a private repository. So you can't really get your hands on it. Well, there's an issue on GitHub where you can ask for access and you can use it, but it's not really ready for production use. It uses protobuf for its communications, and it supports server-side streaming only, no client-side or bidirectional streaming, as the browser standard that's supposed to standardize that, this is called the Streams API, has not been finalized yet, and there's no browser that implements it yet anyway. So only server-side streaming in gRPC Web, unfortunately. But the idea is that the browser becomes just another gRPC client. And as I mentioned, the official implementation is not really ready for production use. However, there is another implementation written by a British company called Improbable, which is written in TypeScript. It uses HTTP2 and transparently downgrades to HTTP1. It also uses the Fetch API and transparently downgrades to XHR for browser support. It also comes with a Go proxy package and a binary, depending on what you want to use it for. So this here is the browser stack. This here is an example of if you're exposing a Go gRPC server, you just import the gRPC web package and you just wrap your gRPC server. It's very simple. If you have any other gRPC server, you just front it with the Go standalone proxy binary. It's also very simple. The proxy is necessary and mandated by the spec because the browser cannot speak the official gRPC protocol. But it's very simple still, so just use it. And it's used in production at Improbable, and I'm not sure if anyone else is using it in production, but I'd be interested in hearing afterwards. So what, can we run Go in the browser? Yes, we can, with GopherJS. Who's heard of GopherJS before? Only half the room? Okay. Well, you're in for a ride. GopherJS is a Go to JavaScript transpiler written by Richard Musial. It's been out for about 4 years or so, I think. And it supports nearly everything in the standard library, including Go routines. It's used in production by certain open source projects such as Perkeep, which used to be called Camly Store, 1PasswordX, and Ninjat, who are both private companies. And there are also community bindings for popular JavaScript frameworks such as React, Vue, the DOM, and WebSockets. So what do we get if we put all of this together, right? gRPC Web for Go, my open source library. So it combines GopherJS with gRPC Web using the Improbable gRPC Web client. It has a Protec plugin that generates GopherJS code with no JavaScript dependencies. It's designed to look like Go gRPC clients, and it has full streaming support. The spec only mandates that you should support server-side streaming, but I was sitting at the Golang UK conference and I had an idea and I implemented bidirectional streaming and client-side streaming with a WebSocket proxy. So you can use that as well with the gRPC Web for Go library. So what can we do with it? You could write a GopherJS browser app. You could write a GopherJS Electron app, for example, and use it to communicate with your backend. Or you could just write a generic front end for your gRPC service. It doesn't even have to be a Go gRPC service. But we're going to have an example later to see what it looks like. And essentially anywhere where the front end talks to the back end. So here's the generated code, and if you just remember back a couple of minutes ago, the Go client generation it's supposed to look very similar to that, so you get a very similar interface with a constructor like this that returns you the interface from the generated code. all this is very interesting, but I wanted to show you what it's look like to work with, so I'm going to do a live demo here. And if you want to follow along, I give you about 10 seconds to clone that repo right there. Francis. I asked him to hold my microphone. Does anyone want to hold my microphone? Very good. Okay. So I'm going to press this button, and hopefully this is not going to break everything. And beautiful. Oh boy. Is that legible at all? Okay. Does that look okay on the live stream? Let's see. Maybe that's just the wrong. Oops. Yeah, can we turn the lights off for the stage?
No, the light mode.
Oh boy. Oh my goodness, I have no idea.
You can turn on the lights, but then nobody will see you actually.
This is a dilemma. Let's see. I didn't think about this. Color theme. Nope. Oh, solarized light. That'll probably do. Is that better? Right. Okay. So, off to a good start here. We're going to. So I've just got a clone of the repository here, and the first thing I'm going to do is disable the subflee compression, which would otherwise run and takes quite a long time, or it takes about 10 seconds per generation, but it's going to stop us from doing anything useful. So for the purposes of this demo, I'm disabling it. But anyway, next step is to replace. Oh my goodness. I'm going to replace the imports of the clone repository, of course, with the repository into which a repository path into which I have cloned my repository. So it's just a simple find command. It's in the README, so you can use that for your own clone if you have. Next thing we're going to run is make generate cert, which will generate ourselves a self-signed certificate. Wow, it's not supposed to look like that, but anyway. Okay, next up, let's just take it for a spin and see if it all works. Logger is not printing it correctly, is it? I hadn't opened the tab. Yes. Fun fact, if you type bad idea into this prompt, it accepts your certificate. Yes, okay, so it works. Perfect. Next up, no, that's not the demo. That is not the demo. Okay, so what I want to do here is show you how to use it a little bit. So I'm going to go into the index.html. I'm going to add a button here. We're going to say click me on the button. And we're going to also add a div, which we can write to. Let's call it a container. And that's saving our index.html. And then we're going to open the proto file. So as I mentioned before, all of this is just controlled via the proto file, essentially. And this boilerplate repo comes with an empty proto file, essentially, with just a little bit of boilerplate for you. So you can just get down to the business of defining your types. So I'm going to define a user here, and I'm going to need some help from the audience to figure out all of the fields that we should add to this. I'm going to add an ID, I'm going to add a name, and I'm going to add an age. Oops, you enter to age. But what else should we put in the user type? Suggestions? Sorry? Email is a good one. Yeah, okay. Let's add an email like so. Look at that, forgot a space. And we're also going to add another message type to, which we'll call user request, and it will soon become very obvious why that's called user request. And of course, that's going to take just an ID. And then we're going to define the RPC method getUser, which takes a user request and returns a user, like so. Boom. And with that, we've defined everything we need, essentially, to then... oh, wow. This terminal got messed up somehow. I'm just going to run generate again. That generates the proto files and also generates the JavaScript and the GopherJS interface. But anyway, we haven't actually done anything in the implementation of either side yet. So what's happened here is we've generated the server, and all of a sudden my type check at compile time fails because my backend does no longer implement the interface that it's supposed to. So I'm going to take that interface function definition, and we're going to of course, implement this on the back end. And as you do, context is called context, of course, and we'll call the request request. And we'll need to add some namespacing here because the tooltip didn't give it to us. Okay, and then the backend is a very bad backend because it only supports one user. And so we're going to check if the request ID is the same as the only user that we support. And if it isn't, then we're going to return an error. And we're going to use the standard gRPC status error type, of course, because we are good gRPC citizens. And we're going to return a not found, which translates to HTTP 404, in case you're interested, and say, well, we can say user not found in this case. So that's basically the correct way of saying invalid ID, if you want. However, once we've gotten to this stage in the logic, we know that the correct user has been specified. So we're going to return, the user that we have, ID 1234, of course. Name, I'm going to use myself here. And email, I'll just put redacted because what? And nil. So that's the back end done. And then we go to the front end. This is all GopherJS code, but of course it just looks like Go because it is, and you shouldn't pretend that it's anything else. And now, hopefully this is all going to look fantastic to you if you haven't used GopherJS before. So if you cast your memory back to the index.html definitions that we made, we've got a button that we can use. And we're going to use the document.get element by ID and get the ID of the button, of course. And then we're going to say that this is a type DOM button. Now, can you imagine doing something like that in JavaScript? That would be amazing. But you can't, of course, because JavaScript is dynamically typed curses. And so we're going to get the container as well. This is why we need Go to save us from JavaScript. And we're going to talk a little bit later about other things relating to the future of the web and Go, but not right now. So with this button element, we can add an event listener. Because we want to do something interesting when we're clicking on the button, we're going to tie it to the event listener click. We're going to disable the use capture, which I don't even know what it does actually, but we don't need it in this case. And we're going to ignore the DOM event input arguments to this function. But essentially here we are. This function is going to be called when we press the button. So what do we want to do? Of course, we want to make a call to the back end, get user. And this is the function that we defined in the profile before, of course. It takes a context. You can use contexts with that's the wrong type. You can use a context with a timeout and stuff if you want to in here. It will all work as expected, but we're not going to bother here because the backend should reply to us in good order. Wrong namespace. Client user request, of course. ID, and because we just implemented the backend, we know what to put here, of course. And we're going to assign those to a user and an error because it can error. And what do we do if we error? Like good gophers, we do if error nil, of course. So we don't want to continue that flow, but we do want to do something. So let's write to the container. We can set the text content to the content of the error. However, if we're here, then we've got a user back from the backend, which is great news because that's what we wanted all along. So then we're going to take the container and set text content to something more interesting. We'll start with the name, and we're just going to do some string concatenation here. Get name, age. Now, age is actually a unsigned integer, so I'm going to have to use strconv. Oops. I'm going to have to do an integer conversion on that bad boy, and there we go. And then we've got also using ID. We've got ID, and of course, thank you, sir. We've got email. Let's see if I got that right. No compilation errors. Okay, now this looks great, right? However, there is one little trivia about GopherJS and JavaScript in general. You can't block on the main thread, so this is going to be wrapped in a Go routine in order for it to execute, otherwise it will not work. But you will get a runtime error, which is not all that useful. So now that we've generated that, we've got the backend, we've got the front end, we're going to run the server again, and that has not worked, so I'm going to assume that I was caching it. Yes. See, in my testing, it would do that about 50% of the time, so I was hoping it was just going to work. Anyway, boom! It worked, right? We clicked the button, we got a request to the backend. Thank you! If you want to, you can be snoopy and look at the information that's been sent here, but that's not what I want to do. Ah, very good. Okay, that's actually right on cue. I just wanted to show as well. This is great, right? But what happens if we give the wrong ID? And as you know, we said to the backend that it should return a nice gRPC error, but how will the front end handle that? And yes, so it gives us a not found error, and if you're used to Go gRPC, you'll know this is exactly what a Go gRPC error looks like. However, this is not all that interesting, because in addition to this, we can do status from error, and get access to things like the enumeration itself. st.code, we can get st.message, and also other trailers. So actually, yeah, we probably have. No, okay, I'm going to skip that because I don't think we have time. So let's go back to the presentation, and yeah, so, all right.
You go.
Thank you, Maciej. So there we go. Yeah, this is the wrong window, actually. There we go. So what we've learned today is we've seen that we can take a simple protobuf interface definition. We can generate a front end and back end, and simply implement the back end, implement the front end, and have easy communications between a GopherJS front end and GopherJS back end, Go back end. Indeed, this is just an example of what you can do. Of course, you can replace the Go backend gRPC service with any other gRPC service. I encourage you to look at the boilerplate repo and on the official repo, which will be linked on my talks page. There's all kinds of examples about using this in different scenarios. And hopefully, next time you want to write a GopherJS app, which should be soon because it's great, you can try using my library. Okay, I'd like to thank FOSDEM and the Go DevRam organizers. I'd like to give thanks to Improbable, who created the gRPC web client implementation, which is really nice, especially Michal Witkowski, who's been doing great contributions to the Go gRPC ecosystem. I'd like to thank Richard Musial for creating GopherJS. He is currently working on a WASM compilation target for Go, which is extremely exciting. If you haven't checked that out yet, you should Google it. Hopefully that will come to fruition at some point soon. I can't imagine anyone better than Richard to be working on that kind of thing. Dmitry Shryalov, who's appears to be the main maintainer of GopherJS, it gets updates every major Go version or so, because there's all kinds of new things in the standard library. You need to make sure that it's compatible with GopherJS. And the GopherJS community in general is great. You should check out the Slack channel on the Slack GopherJS. I'd like to thank Travis Klein, who gave me the idea to implement my own WebSocket streaming proxy from his proxy, which is for the gRPC gateway. So if you're using gRPC gateway, you should check out that library as well. It allows you to do streaming in with the gRPC gateway. And also Paul Jolly, who has pushed me to present my own work, and without whom I wouldn't be here today. And last but not least, I'd like to thank you for listening to my talk. I hope you enjoyed it, and I'll take any questions you might have now. Thank you. Okay, no questions. Thank you, Francis. Anyway, yeah, you should check out the talks page. There's tons of links on there, and you can start playing around with it yourself if you like. Yes. Yeah, so a longer version. Sorry, yes. The question was, it appears that GopherJS generates large JavaScript files, essentially. This is true. And a longer version of my talk would have talked a little bit about how to work around that. But you just noticed how I disabled the softly compression while I was doing the presentation. The softly compression introduces something like an 80% compression rate, which is really nice. It will bring the 2 megabytes down to about 300 kilobytes, which is still quite large. And in general, when you're working with GopherJS, you have to be a little bit careful about what packages you import, which is a bit unfortunate. But if you, 2 megabytes in this case is actually probably an example of a small file. I know the per keep generated file is like 9 megabytes, which is awful. And it's probably, in my opinion, what holds back GopherJS adoption the most. But as I said, with gzip compression, which softly is essentially, you can get it down to much more manageable file sizes, and this one in particular will be about 300 kilobytes, which is acceptable, I think, for most people. Yes, thank you, Francesc.
So, do you think, this might be a throwing question, so you will need to answer it, but do you think that WebAssembly will make GopherJS irrelevant?
The question is, will WebAssembly make GopherJS irrelevant? And my personal answer is, I hope so. And I hope we'll be able to just write Go code, produce beautiful WebAssembly code with none of the JavaScript rubbish, frankly, that we have to deal with today. I'm eagerly awaiting the first beta when Richard, if you're watching this, Richard, I'm your biggest fan. When it's ready, I am ready. Okay, thank you.